Hello everyone, in this video I'd like to talk about in the Beckhoff TwinCAT 3 system, how can we snapshot the PLC online value to an offline file. This is a very important feature to allow us to capture or snapshot all the important setting point or some important recipes values to an offline file so we can offline review the values. Any cases you need to review or you need to restore those values back to the online controller. Or we can copy the important settings to another machine, to the next machine, if you are the machine builder. In the Beckhoff system, it doesn't have one existing buttons to allow you to capture the online values to an offline file. Comparing with the Allen Bradley or Siemens system, these two brands has an easy way to do this snapshot function. But the Beckhoff system does not have one direct button to realize this feature, but we have an alternative way to do this. Before we start this topic, I do want to review to another topic. The first one, that's the variable persistent. The variable persistent allows you to archive all the value into the controller. For example, in this picture, this computer running as the TwinCAT PLC, running as the controller. And if this controller shut down, because we know basically all the Beckhoff system is running in a PC, if the PC power shut down or the Windows system shut down, can the important values can be stored into the PC, and after the system recovered, restart, can all the set point recover? The answer is yes. So if you set a variable as persistent properties, so all the important value can be stored. But all the values can be stored into the controller. You are not able to see them, but all those values will not be lost. They can recover after the system reboot. So from the HMI, you can still see those values after the Windows system restart. So this is the first topic. This is the variable persistent. You can find the link below this video. The second is a CSV function. The CSV function allows you to archive the important values, the variables, into a specific CSV file. The CSV file is a common file can exchange with other systems. So other systems can steam this to exchange some data between the controller and other software. This is the CSV file. But most of the factory style or the machine control system, the programmer or engineers just want to archive all the important values to an offline file. For example, the PID settings, valve settings, speed variable settings, and the PID parameter settings. They want to capture the important parameters from one online running controller to an offline file. So all the important value can store somewhere in case the HMI setting got messed up. They can recover all those important variables from an offline file to the online controller. Therefore, today's topic, Recipe Manager, the feature from this Recipe Manager can realize this feature, archive the online important values to a file. Before we discuss this, we can review how the Siemens and Allen Bradley system does this snapshot, because this snapshot is kind of like a terminologies. To easily understand how the snapshot works, let's review one video from my channel. Alright, if you search electrical automation hands-on, so you can search my channel, electrical automation hands-on, and let's jump in and let's go to the playlist. Let's find out the Beckhoff TwinCAT controls this playlist. Okay, and then let's click this playlist, and you can see this BK06. This is the how to retain variables. This is the retain topic I just talked. And regarding the CSV, we can scroll down and view the BK17, Beckhoff TwinCAT 3, Datalogging or recipe via the CSV, reading and writing. And in this video, I discussed how can we use the CSV file writing and reading to realize the Datalogging, the recipe value. So today's topic will be another alternative way to do this and a more common way to archive some important values. And in addition, in this video, I also discussed the snapshot function from Siemens TI Portal and Allen Bradley Studio 5000. So let's go here. Once we open the DB, we can see the top area here, this bar. So while we are online, you can click this snapshot. You can see this icon is very straightforward. We can snapshot all the online value in this DB. While we are online, we can click this snapshot. So using this button, we will see this direction. So that means we can online capture all the variables in this DB and capture it as one buffer. And then we can click the button, copy the snapshot to the start value. Then from the start value, this column, we are able to see all the online value it was. So we can offline review the variables, the values while they were online. Okay. Also, we can store all those data, and the next time if we have the new machine, we can download all those values for the second machine. So we can click this, load start values as the actual values. Click this button. Then all the values stored in this DB, we can download to the next new system. So this is very convenient. This is the Siemens TI Portal system. And for the Allen Bradley system, it also quite straightforward. So in this picture at the video 330, while you are online with this controller using the Studio 5000, once you click the save, then all the values they were online will be captured, will be saved at this value column. Then they will be stored here. If you offline the project, you can still able to see all those values they can capture. So as we can see, if you have the temperature settings, PID parameters, or very important recipe values, they can store that here. Also copy to the next new machine. This is a very useful feature. But if we go back to the Beckhoff TwinCAT 3 system, for example, now you will see all those variables came from the GVL, this variable list. So you will see all the online value now. But if I log out, then the offline view will show like this. You are not able to see any value they were online. You are not able to see all the values behind this structure. So the only way you have to go online and see. And once you go online, you can expand here and see all the values in here. So here, if we have a snapshot feature available, once we click the snapshot, then all the important value can be saved, can be restored. For example, now I can snapshot my current value at here now. So from this program, I can snapshot, trigger this save recipe feature. Okay, so it captured now. All the variables captured already, and all the values stored in a file. Now I intend to wipe out all those online values now, so I can restart the system. All those values without setting any persistent. So once I restart this controller, all those values will be lost. So now I restart. Okay, restart. Okay, once I restart and go online, log in again, so you will see all the values lost. Okay, all the values lost. But fortunately, I snapshot the important values I discussed today, so we will see those values will be recovered. So if I go to my program here, I have this read recipe. So basically restore all the value. So once I trigger, now if we go back to this GVL again, we will see all the values can be restored and all the values back up. So you can imagine like the PID parameters, some valve side points, they are very important. Using this feature, we can restore all the important values. So the topic today we'll discuss is this recipe manager. Okay, let's start this topic. Let me show how can we implement this feature step by step. We do need to program something here. Let's go to the TwinCAT 3 system. And in this project, I create one empty project that's specially showing this case. And under this project, I create one PLC project and name this PLC project as Snapshot. And now my laptop is connecting one PC, and that PC specially run as the TwinCAT controller. So that's why this connection here, and the PC I'm using, this is Sync Center. If I go here, if I go to the routing setting here, I'm connecting this PC. So to connect one PC, you can type in the IP address and we can set up the connection. Now I set up this connection and I'm using the trial license now. And from this real time, I'm using this isolated core. In this controller, in this PC, it has 4 cores inside. So I'm using this isolated core. So click this read and you can set the isolated core and set this on the target. So this PC will assign one isolated core, especially run the TwinCAT controller. Okay. And now I can download this controller. So firstly, let me show like a regular project, what is showing now. So I'm gonna download this controller. And in this project, I have one GVL variable list. And if I double click, we will see this GVL variable list. I have 2 bool, 2 integer, and 2 real. Okay, this is the typical data in the controller, right? So now if I go log in, I download the controller, I log in. For example, I set to on this, and the integer I can set to 10, or this real one I can set 3.14. While we are online, we can see the values. But once we log out, we can now see the real value is using or the actual value in the controller. That's why in this video we are talking about how can we use this Recipe Manager to snapshot the online values. So once we archive those important values, we can see the values offline. This can use for archive the important values or set point. And also I will show another case. As we can see, this is a very simple way. This is the individual variables. If we have some structure, so in that structure, we have a PID parameters or other parameters. Especially in the structure, we also have an array. So how we can configure this recipe values. Okay, so now let's go to the recipe setting. So this is the one regular project. We start from here. So to enable the recipe, we go to the project. Under this PLC project, let's right click, click this add. And we will find the recipe manager. Recipe Manager. And we will see the Recipe Manager. Let's open. So the system will add the Recipe Manager under the PLC project. Okay, once we create this Recipe Manager, we will see those selections. From this store type, we will see only 2 selections, the binary or the textual style. Basically, we will select the textual style. So once it archive the file as a text, so we can open this text file by the notepad and we can see the values in this notepad. If you do have some value doesn't want to show for others, you can set up the recipe manager as the binary style. You can now see the values directly from this file because this is the binary style. I believe most of cases you like to set as a textual file, so you can even do offline view, or you can offline change this value and you can reload back to the controller. So you can load the different recipe, right? This is named the recipe. So you can offline prepare some values in the recipe file and load the file back to the controller. That's why the textual will be more convenient and more regular. Okay, and then the file path. The file path is very important. This is used for store the file. Basically, the file will be located into your runtime controller. For example, firstly, let me jump into this sync center, this PC. Let me create one folder. Okay, I will use the remote desktop. Okay, remote desktop. So this sync IPC, that IP address is 1.130. All right, I'm using the remote desktop, jump into this sync IPC. So I will create one folder. So I will create a folder. Okay, this name the recipe, this folder. Okay, and then go back to the engineering station, the engineering laptop. Now we can configure the file path. And this syntax is a C:/, and this is your directory. And make sure this directory represents your runtime system. And the file extension, so basically we will leave as a default. Don't change to others. Okay, so this is the text. And then the separator depends on your country. So basically, I will leave as a default this equal. Once we archive the file, we archive the value into the file, you will see how this works. Okay, the last things, this is very important. Which kind of columns we can show in the archived text file. Basically, we will leave the name, the variable, the current value, and the date type. The last one is a current value. So we will see the current value very easily. Okay. And then the next tab is a general. 99% we will leave those selection as a default. Okay. Go to the storage. We finish everything and we can click this save as a default. We save here. And this is the main selection. And then where we can select the variables we want to archive to the recipe file. Then let's add the recipe definition. Keep in mind this keyword, recipe definition. So you can create the multiple recipe pages. Here, I'm going to create the first one, recipes 1. Okay, recipes 1 here. And we will see the right side here is showing up. This is the place to select the variables. So for example, I'm going to select the variables from my GVL, those variables. So from here, we can select the variables. My variables under the PLC project, the GVL. So we will see those are the variables. So we can pick the first one, bool. Okay, bool is selected from the GVL.bool1. Okay, and select the next one. Okay, we select the next one, bool2. And select all of them. So from here, it doesn't allow you to select the multiple variables. So this is a little bit annoying. So you have to select one by one. And this actually come up another topic, which way is an efficient way to select the variables. I will explain those shortly. Okay, select the variable 2, integer 2, real 1, and the real 2. Okay, those are the individual variables. As we can see, select one by one is really annoying and time consuming. So in this project, I especially create this case, this structure named the snapshot. In this structure, it has the important setting point values. For example, the valve with velocity values and the control mode. Most of cases, you would have the manual mode or auto mode or enable or disable mode, right? Or for the PID, for example, I could have 3 PID loops, and I'm using the array 1, 2, 3. There are 3 elements in this array, and this array is also based on another structure. This another structure come from here. So we will see, we assume this is one PID control loop, and each PID control loop, it has a gain, integral, and derivative, right? And also has a set point. And I have 3 control loops. So that's why this array st PID parameter that includes 3 array elements, and each array element, it has couple values. And in this big st snapshot, it includes all those variables together. So if I go to the GVL, so this time I can name this one as st recipe values. Okay, and this based on this structure st snapshot. So this data type is st snapshot. Okay, so this st recipe values includes all those variables, also includes those elements in this array. Okay, so this time let's use this recipe manager to import this recipe values. So this time if I go to the recipe, and here I'm gonna close this and select, and we will see this time GVL, under the GVL, it has this recipe values, and we can see under this recipe values here, and it includes 3 arrays. It has 3 elements, and it's also this relay based on this PID parameter structure, right? And it also has the real and the bool value. So if I select this structure, it includes a bunch of values inside, right? So if I click OK, then enter. So we will see the system automatically expands all the variables behind. It won't be like showing as a structure, because in this recipe, you need to show the individual values. You need to show all of the values in this variable, in this global variable. So I have 3 arrays. This is the first array. This is second array elements. This is third array elements. So we can see you better create one structure. And within this structure, you include everything. So when you create this recipe values, it will be very easy. You just select this structure variables, and then it expand automatically. Now we include everything, so we can save. And keep in mind, now it named the recipe 1. Okay, so we finish all the configuration, but now the next things we need to program something. Basically, that program allows us to trigger the save, trigger the create file, save the file, and load the file. Okay, let's shift to the programming wise. Once we create this recipe manager, we'll see from this reference here, it automatically create one recipe manager. This reference. If we double click, we'll see it includes the interfaces, general types, and more importantly, this recipe main commands. And this recipe main commands includes all the important methods below this. So if you search TwinCAT object recipe manager, you will see this help page. Okay, it explained the detailed selection here. And also, if you click this library recipe manager, this recipe main commands. So it explains the important key function block we would use. Basically, we would use the 3 typical function block. One is the create recipe. We need to create one file, right? So we will call this create recipe. And after the create, we would call the read and the save recipe. You will see this explanation here. This method read the current PLC value into the recipe. Basically, that archive all the important value to the recipe, to that text file. So we will call this read and save recipe. Okay, and if you offline change something and now you want to load the value from the recipe text file back to the controller, then we would call the load and write recipe. If we scroll up, we would use this load and write recipe. So this method load a recipe from the specific recipe file back to the controller into the PLC variables. So this is the 3 typical methods we would use. So now let's go to the TwinCAT project. Let me show step by step how to program this. Okay, we will use this recipe management. Okay, let's go to the GVL and let me call a global variable list. I will name the recipe manager. So I can call that RM, recipe management. Okay. I will declare a couple important variables. Firstly, this is the function block, the instant function block. I will call a function recipe main commands. Okay, and its data type will use this recipe management, and its function named this recipe main commands. Okay, and type in the name recipe main commands. Okay, this function block. And from this function block, it includes multiple methods inside. So when we call this function block, we will call the detail function block. Okay, so if I expand here, we will see all the methods in here. Okay, and then I will create 2 variables to receive the result, the feedback echo from the system. So we can call that DW. This is the Dword result recipe save, and this is the Dword, and another one, this is the DW result recipe read. Dword. Okay, so this is the 2 feedback values. So If those values shows a 0, that means okay. If it has error code, it will show some code. Okay. Then we will create toString. That toString is used to set some important directory and a file name. For example, if we want to operate this recipe configuration here, it named the recipes 1. Okay, we will set something for this. So now let's create a toString variables. So string recipe. This is recipe definition name. We will tell the function block, okay, we are going to operate this file. So if you recall, when we create this file, it creates a recipe definition. So that's why we create this name to align this name recipe. We align this name recipe definition name. So this variable, this is a string. And we will set an initial value for this. For example, recipes 1. Okay, this name the recipes 1. Okay, here. So second, this is another string name, recipe file name. What's the actual name of that file? So it is also a string. We can name the file as the recipe file. Okay, it will name like this. Then we will create a 3 trigger. Because all those functions, the command is a trigger command. So we need to create 3 triggers. We could have a 3 rising edge function block. So we will use the R trigger. So the first one, R trigger. So firstly, let's declare the command. So the first command, that is to create a recipe file. Okay, this is the bool. And second, after create, we will save recipe. Okay. We can create this create a recipe command. Okay. And this is a save recipe command. And the third variable, we can read the recipe. Read the recipe basically load the values from the recipe back to the controller. Okay. This is 3 important variables. And then using the trigger, we will create the function, the instant function block by using the R trigger. So first one, this is the create a recipe R trigger. Okay. That function named R trigger. Okay. And next one, we will create FB save recipe R trigger. Okay. The third one is named instantDB read recipe R trigger. So we declared all the important variables. Okay, and we can click the save. All right, we created those variables in this RM Recipe Manager. Okay, and then we will see usually our program locate the main, and basically the main will be called by this PLC task. And the PLC task, the cycle time is a 10 millisecond cycle time. So usually when I use this recipe manager, I will create another slow PLC task because sometimes if you have a tons of data stored into the file, it needs a longer time. If you are still using the same main, same PLC task, this PLC task default is 10 milliseconds. If the processing time is longer than 10 milliseconds, it will cause some trouble for your regular control program. So that's why usually I will create the task which has a longer processing time. So create another PLC task. For example, here I will create a task that I name the recipe. Okay, we create this task recipe, this PLC task. And default the priority, this is 1. The lower value here that has a high priority, but actually we can set a lower priority than the regular PLC task. So the regular priority is 20, so we can set a 21. That has a lower priority. And this is a cyclic tick, we can set a longer, for example, 20 milliseconds. That has a longer PLC task. Okay. So while we are processing the recipe has a bigger file, so it won't cause any trouble for the PLC task for your regular control, especially if you are using the PLC task to processing some motion control. So when you read or load the recipe file, it could cause some trouble. That's why here I create a longer cycle tick and a lower priority. Okay, we create this recipe here, and now let's temporarily save the project and build. Let's build a solution temporarily. Okay, we build the project here, and from here, let's manually create another this PLC task. So let's add a PLC preference task. And this preference task, this is the one task we just create, this task recipe. Okay, let's click this task recipe. And then from the POU, we will create another main program for our regular control. So from here, I will create another program. So POU, and I can name that program recipe. Okay, we create this program, and then we can assign this program be called by this task. So now let's create existing items under this task recipe. So we can pick this one, program recipe. Click OK. Okay, now we can program some code under this program. So firstly, let's program something to process this trigger. So if we go to the program here, so firstly, we can use the input assistant to call the instant DB. The instant DB that locate the RM. The first one, this is the create recipe R trigger, right? And then from this trigger, we can call the RM variable dot create a recipe command. Okay, this is the create a recipe command. Okay, next one, we can still use the input assistant and that name the save. Okay, click the save, call this instant function block, and the variable rm dot, that's a save command, save recipe command. Okay, and then next one, we will call that read recipe trigger. Okay, the trigger variable named, this is the read command, read recipe command. Okay, and then we can create, while the create recipe, this queue equal to on, then we will call that recipe create, the method, the function block. Okay, so if this trigger, this instant DB dot queue equal to on, then we will call that create a recipe. So how can we call that? So we can still use the input assistant, and we can call, so using the instant calls, and we'll see this is the instant, that function block. And now we will use the method within this recipe main commands. This is a big function block, instant big function block, and we will call that create recipe. Okay, here. If go to the right side, we will see this is create a recipe allocate here method. Okay, we can click OK. And meantime, we will see this explanation here. This method read the current PLC value to a new recipe and save them as a recipe file. Okay, and this method is especially used to create a new recipe file. Okay, click OK. And this function block that comes from the RM, so I will type in the RM as a prefix. RM, this recipe. And recipe name, okay, this definition recipe name. How we can type in the variable here, if we recall the RM we create, I will drag leave here. So this is recipe name that come from this definition name. So this tell this method, this function block call, we will operate this file, recipes1. Okay. So here we will use this variable recipe definition name. Copy and paste here. And not enough, its prefix is the RM. This variable comes from this global variable RM. and the recipe name. This recipe name is a file name once we save the data to the file, the text file. So the text file that it comes from here, the recipe file name. Okay, we can copy and paste here. And same thing, the prefix name rm dot. Okay, comma. All right, we finished this. So this one we'll use to, this is the create. Okay, this is the create recipe. Okay, and same thing now. After the create, we will save the data to the recipe, right? So we'll say if the save recipe, this trigger equal to 1.q, then we will call that save. So the save we will call here, still use the input assistant. So from this instant call, from this instant function block, the recipe we will use the read and the save recipe. So we can see it reads the current PLC values into the recipe and afterwards stores the recipes into the standard recipe file. This is the text file. Okay, and you can see the explanation for this inputs, two inputs. Okay, all right, let's click. Here will be the same thing. So we will operate the same file. That's the recipe 1. Okay, so we'll use the same name here, the recipe definition name. That name, the recipe 1 here. So we'll copy and the recipes, this file name. And the key reason I'm using the strings as the input. So in case you have multiple files, recipes 1, 2, 3, 4, so you can change the recipe's name. So you can operate the different recipe files here. You could have multiple recipes files under this recipe manager. Okay, so we finish this. So this is the save. Okay, don't forget the prefix rm dot recipe file, recipe test file. Okay, and third one, if this is read, so we can read the variables from the offline file back to the PLC data. So when this trigger .q equal to 1, we can load the recipe's value from the file to the PLC. Then we will use the function method named load and write recipe. So we will see this loads a recipe from the standard recipe file and write the recipe into the PLC variables. Take care of this direction. Okay, click OK. Okay, and the same thing, if you are going to operate load the file, your target file is the same file. I can copy the same variables at here. And the recipe's file name, same file name here. So we finish those key program and we can save. And this program will be called by this task again. Don't forget, we have to download this hardware configuration because we config this. This is somehow is a hardware configuration, and the program will operate these things. Okay, so let's build the project and click this active configuration. Okay, let's click this active configuration. All right, now the status changed to online mode. So firstly, let's go to the GVL. We will see after we reboot the value gone. So we can type in some new values here. So bool 1, we can set 1. And the integer, we can set 100. We can set 100. And real 1, we can set 3.14. Yeah, and we can transfer. And in the meantime, this recipe's value includes a lot of important set point. For example, this valve set point, we can set 20.5. Okay, and the velocity, we can set 200.5. 50. Okay, and this control mode we can turn it on, transfer. Okay, and the PID parameters, it includes 3 elements, and each element it has bunch of important key parameters. So we can use one as an example. So this set point we can set 50% or 50 the temperature. Again, we can set 0.5, and integral it can be 2000, and derivative, for example, 10. Okay, we set the first elements. We can leave others as a 0. Okay, and we have some values here. And again, all those variables we configured into this recipes 1. Okay, and from this recipes 1, once we double click, we will see the current important values, what the current values of them. Okay, and now if I go to the program, this recipe here, so these 3 commands we can operate this recipe operation. In the meantime, I can open my target, this target sync center, this IPC, and we will see currently I haven't operated anything, so that's why under this recipe folder it doesn't have anything. Okay, now if I click this create recipe file, I trigger, double click, and I click this write value. We triggered, and then we will see after I click the trigger, it create one file. And now if I click this save, it will save the variables according to when we click this trigger. So if the sum value equal to 20, change from 20 to 30. So once we click trigger this save, it will change to 30. So now if I click this trigger, save trigger, boom, trigger. So as we can see, it's operating the recipes 1. This is recipes 1, and the file name named the recipe file. Okay, I'm gonna turn off this trigger. And in the meantime, if we go to the controller, we'll see this file named the recipe file. Okay, same name as here. And the configuration comes from the recipes 1 here, from here to here. Okay, and then now if I open this file, okay, let's do a comparison. If I click this recipes 1, so if I shift to the global variable here, and the right side, I will open this recipes file. We'll see the files looks like this. So the bool 1 equal to true is saved. And PID parameters 50, 0.5, 2000. So PID parameters 1, that 50, 0.5, and 2000 is showing here. The important values in the variables we archived, we store that here. So the PID 2 and 3, currently they are 0. So now if I change something, for example, this is the offline file, right? So if I change this PID parameter, this set point to 35, and again, let me change to 0.8, and the integral I change to 1000, okay? And this derivative I change to 20, okay? Then I can click the save, and I can close this file. And now this PID parameter that equal to 0, okay? This is all the current value. And now if I leave this values, this variable monitor here, and now if I go back to the program, if I trigger this command, read the recipe, so this will load the offline variables from the recipe to the PLC. So if I trigger this variable, trigger, we'll see at the same time the offline values in the text file will be loaded back to the controller. And in the meantime, all those variables, no change, because we didn't change those values. This is very useful. We can load the variables from the file back to the PLC controller. So you can imagine if you have some files, if you have a different files prepared offline, so you can trigger the command, load the different file back to the PLC. It's very convenient, right? And while you are trigger this save, this recipe, this command, basically it's doing, I'm gonna turn this off. Basically, every time we trigger this save recipe command, basically it's doing the snapshot. It snapshot all the important variables, depends on how you configure those variables. And in the meantime, those variables can come from the structure. So within this structure, you can configure everything, all the important variables, just in this structure. So when you call configure the variables, you can only configure this recipe values because this recipe values come from this global, this recipe values that they type, this is the structure snapshot, come from here, right? So this configuration could also be very convenient. You do not need to type in one by one. You just need to call config this entire, this top level, this variable name. Okay, and then let's do one more thing. Let me go offline. When I declare these variables, I declare this tool. So this tool can feedback the operation status. So in case for save or load back to the controller has something wrong, we know what's going on from this tool operation. We can use these two variables. This is save and the read. So I can copy these variables. Let's go to the program here, the save. So we can feedback the status. So the feedback status is equal to these values. Okay, and these variables come from the Recipe Manager, RM. And same thing for this read, that name the read. This is the Dword variable I declared, right? So RM. Okay, now let's log in. Okay. All right, we load back in here. And this time I can create some new values for the PID 3. So all the values are here. So I can create the 3. For example, 60 and gain could be 10. And the integral could be 200. Okay, I create here. Derivative could be 300. Okay, and write the value into this PID 3. And now go to the program. Okay, we will see this save these variables. If this variable equal to 0, that means okay, everything okay. So if I trigger this save this time, boop, save. And now let's go to the target PC and let me open this file. So we will see the third element PID, so 60, 10, 200, 300. Okay, they all stored here, 60, 10, 200, 300. Okay, so if I leave this as an empty this time, and then I will load this file with this empty value back to the PLC. Let's see what will be. So if now I trigger this read, it doesn't show the error. That means it's operating correctly. But now if I go to the GVL, so that means if you leave this empty, it won't override the online PLC value. Okay. But one more thing I like to show. So now if I go to this file, we will see sometimes the PLC will write some value showing like this style. Showing like this style. So actually this is the real value, 3.14, right? 3.14 here. But it comes with this. So this somehow the PLC will operate like this way. If I'm going to change the offline value here, but leave this value here, it could cause something. So now if I change this 3.14 to 6.28, for example, click save and close it. Okay, and let's monitor this value. Now I'm going to operate. Trigger the read. And in the meantime, let's watch this status. Trigger read. Okay, no error. Okay, and if we go to the GVL, so we will see the 6.28 will not be load from the file to here because the format, it doesn't like that. By some reason, sometimes when the system archive the real value to this file, it will create some variables like this. So to allow some offline value can load back to the controller, we need to delete this area. So let's delete this. Okay, 6.28. So this time we can change another value, 12.56, for example. Delete that tail. Okay, this time let's save exist, and let's load, trigger the load. Okay, let's trigger this read. Trigger 12.56, then load to this real one. Okay, so don't forget you need to delete. Okay, here. Okay, we can see this is very useful. Okay, the last test I will show the result showing the sum status here. Now I'm pointing to the recipes 1 that come from this data. So if we have multiple recipes here, and by some reason accidentally I type in the wrong name. For example, here when I try to operate the save to the wrong recipe's name. For example, if I'm trying to write another name, recipes 2. I'm going to save the data to the recipes 2, but in my configuration, it doesn't have this recipes 2. So let's see what it will be. So now if I'm going to trigger this save recipe command, boom, we will see the result will show now equal to 0. So as long as this result now equal to 0, that means the operation has something wrong. So you can show this result or show a very easy comparison while it's equal to this, or not equal to 0, you turn on, that means alarm. You show some alarm from your HMI. All right, this is the operation to operate these recipes. Again, if we go offline, and we can create another recipes file, different recipes file. Next one will be the 2. So you can configure the different variables. For example, the recipes 2 just used for operate this recipes variables, this big variable. It has a structure behind, right? So I can click OK. Then it automatically expand all the elements belongs to this variable, the structure variable. Okay, so I have the recipes 1, I have the recipes 2. But keep in mind, if now I directly log in the program, I create this recipes 2 this time. Okay, we log in the program. Let's jump to the program there. And this time, this recipe definition name, this is a recipes 2. So let's see if this time it can operate. And in the meantime, we can watch this target runtime controller. Okay, let's trigger this create, trigger create, and trigger save. And let's see this result. Trigger save. Okay, it operates successfully. And in the meantime, let's go to the target. We'll see this recipes 2. And if I open this file, click this notepad. So we will see this recipe values stored into this file. So the things I like to show here, so if we have to create another file, and when we log in the program, after we create this recipes 2, we do not need to activate the hardware configuration. That means the entire controller do not need to shut down and restart. We only need to do is, once we create this recipes manager file here, and when we log in, after we configure this recipes 2, and when we log in the program, so we only need to check this, update the boot project. So once we log in here, the controller do not need to restart. Then the new recipes configuration can be loaded into the controller. So this is very useful. If your control system is running online, and now you come up this idea, okay, so I need to create another recipes file. Then you do not need to restart your controller. You create a new recipes file and change this recipe definition name to this file name and click this save the recipe or create and save the recipe. Then you can store the important values to your offline file. So this is very convenient, right? But the first time when you activate this recipe manager, you need to activate the hardware configuration. But once you set up this recipe manager, create those individual recipes file, you do not need to download hardware configuration. So I highly recommend for every project you can activate this recipe manager. And also you will see active this recipe manager, it doesn't need any special license. So I'm using the trial license here. So I believe every important project, it definitely needs something to offline review your important variables, like this variables. So using this recipe function and archive snapshot all the important values as a file showing here, that's very useful. Alright, this is the topic for today. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.